What's up, students? All right, back at it again with another FRQ question. That's a little redundant. Free response question. Whatever. All right, so this time, let's jump right into it. We got a person on a bike here, and it looks like he is twice as far back as this skater guy over here. The bike's tires rotate n times per second, and the skater's wheels rotate 5n times a second. So if we look at the tires, we can also see that the bike tire is 8R and the little skateboard wheel is only R. So the bike tire is going to be 8 times as large in the radius. All right. So for part 1, it says find the angular frequency of the tire and the wheel while they're spinning. And number 2 is who is moving faster and how many times more, how many times greater. And number 3, who wins the race? How far behind is the other person? All right, I want you to pause it on this screen, and I'll let you give it a try. Okay, for the very first one, we're going to try and find angular frequency. So what is angular frequency? Here I'm going to be drawing just a couple of problems, 2 little examples. So we have a, let's say a tire that goes around and changes this angle here in 10 seconds versus a tire that changes the other angle in 5 seconds. So which one would have a greater angular frequency? Well, it'll probably be the one on the right because it changes a larger angle in less time. So remember, angular frequency is just how fast the angle something changes. So it's angle per second. Okay, so let's look at our bike tire this time. Now, we're going to say it is going to revolve once in 1 second. Okay. So we know it revolves once in 1 second, and we can consider 1 revolution to be 360 degrees. That's just a conversion. Or we can say 1 revolution equals 2 pi radians. Well, instead of 2 pi radians, we can also just say it's 6.28 radians. Now it gets kind of confusing, radians, degrees, and all that stuff. It's really all just different units like inches, meters, miles, whatever. So I'm going to draw 3 examples here to kind of demonstrate that. So in the first one, we have a single revolution. In the second one, we've got the angle is 1 radian, and in the third one, that is 1 degree. Okay, so it's just a matter of units. 1 revolution is the biggest, 1 radian is the next biggest, and 1 degree is the smallest. Okay, so back to our problem at hand. We know that the tire rotates n times in 1 second. It's not just 1 time, it's n times. We don't really know. Okay. So we know we can say instead of revolutions, we can change it to be 2 pi radians or 6.28 radians. Because we know 1 revolution is just 2 pi radians. So that means our angular frequency, which is omega as seen as symbol here, is just n times the revolutions per 1 second. And we can change that revolutions to be 2 pi, so our angular frequency of the bike is just 2 pi n radians per second. And if we look at our little skate wheel, this goes 5n revolutions per second. So it's 5 times as many revolutions. So the angular frequency of our little skate wheel is going to be 2 pi 5n radians per second, or 10 pi n radians per second. All right. now looking at number 2. Which moves faster and how many times more? So right here, we're going to start with our bike. And when one tire revolves, what happens is the distance the whole bike travels is equal to the circumference. So our tire, it has 8, its radius is 8r, and we know its circumference, which is 2 pi times the radius. Our circumference in this case is going to be 2 pi times 8r, which is 16 times pi r. And so basically when one tire, when it revolves once, we know that the bike traveled 16 pi r as the distance. And if it rotates n times, to find the distance traveled, it's just n times 16 pi r. If we want to find velocity, we do the total distance divided by time. If we know the total distance is just 16 pi r n, and we divide by the amount of time, we know it rotates n times in 1 second, then we know that our velocity is just 16 pi n r. And that's for the bike tire. If we look at the little skate wheel, it has a radius of just r, which is going to be 1/8 of the bike tire radius. So it's a lot smaller. And as we can see, when this rotates just once, the distance the whole thing travels is 2 pi r. But it goes 5 times as faster because we know it's 5n rotations every second rather than just n rotations per second. So it's spinning 5 times as fast as our bike tire. Okay, so our velocity is basically the total distance traveled, which is 5n times the distance of one rotation, 2 pi r, divided by 1 second. And that means our velocity is going to be 10 pi rn meters per second. So now let's compare the speed of both cases. So we got our bike, and the velocity is 16 pi nr meters per second. And for our little skate wheel, or our skateboard, it's 10 pi nr meters per second. So which one is larger and which one's smaller? Well, we know that if you look at it, 16 versus 10, so the velocity of the bike is going to be larger. And if we take a ratio to find how many times more greater it is, we can do 1 divided by the other, a bunch of stuff cancels, and we get 16 over 10, or 1.6 times greater, or 16 times more speed. So the bike is 1.6 times faster than the skateboard. Okay, so now we're going to look at number 3. Who wins the race and how far behind is the other person? Okay, so to find this, we're going to basically be comparing the times. Which one has takes less time to get to the finish line? Okay, so for this one, to solve for t, we're using our kinematic equation. T is equal to distance over velocity, and distance the bike went was 2d, and the velocity was 16 pi nr, so total time is d over 8 pi nr. Time for the skateboard, it traveled d for its distance, and its speed was 10 pi nr. So if we compare them, we can see that the time for the skateboarder is less. Okay, so here's a little picture of the finish line. And we can see that the biker still has a little bit of time left, or he's got a little bit of distance left to go. And we're going to try and find that distance out. That's how far behind he is. Okay, so we're trying to find, first we need to find how far the bike traveled in the amount of time that the skateboard took to finish. So t is the amount of time the skateboard took to finish, and we're going to use that for the biker. So velocity of the biker is 16 pi nr, and the time it took for the skater to finish is d over 10 pi nr. So if we plug these in, we end up with 16d over 10, or 1.6d. So we know that the biker in this time went 1.6d, not quite 2d. The total distance was 2d. The distance he went was 1.60, so that means he's 0.4d behind. All right, so glad we got to this. If you have any questions, leave them in the comments, and or you can bring them up in office hours. All right, have a good day, have a good week, and talk to you later. See ya.